So guys, once again welcome back to Ahoy Navigos. We are back again with one new topic today, meteorology. So let's discuss wind triangle in meteorology today. So let's look into our basic concepts of wind triangle and the terms related to it. First thing, what is true wind? True wind, it is the direction and force of a wind experienced by a fixed point where observation is not affected by motion of the object. Any object which is not in motion, then the direction and force experienced by that object is called as your true wind. Next thing, what is apparent wind? It is the direction and force of wind experienced on a moving object. It is the sum of both true wind and motion of object. That means in true wind it was a fixed object, and then the same case where it was a moving object, then it will be called as your apparent wind. Then it is the sum of both true wind and due to the motion of object. Wind experienced due to your true wind, also due to your motion of your object. Next thing, naming of wind. Wind is named always from where it is blown. That means it's always named from where it is coming from. So let's see some examples for that. If the wind is blowing from in this direction, it's towards 045 and it's coming from 225. That means this wind will be named as wind of 225, not 045, because it's always named from where it is coming. It's coming from 225. Similarly, in this case, it is coming from 045 and is going towards 225. The name is always from where it is coming. That's where it is blown. That means the name is 045. Similarly, in this case, it will be 270. This case is coming from north, so it's northerly wind. Coming from south, it's southerly wind. It's 315 where it is coming, and the last one, it is coming from 135. So guys, these are the examples for us. So now, how we understand both true wind and apparent wind. We will take an example. A ship steaming north at 15 knots and there is no true wind. Still, observer on ship will feel apparent wind of 15 knots. Why is this? This is due to your ship's movement. As we said, true wind is for a fixed object and apparent wind is for a moving object. And for the moving object, it is the sum of both true wind and due to the ship's movement. So that means in this case there was no true wind, but still the ship was moving at 10 knots, 15 knots. That means there is an apparent wind of 15 knots. It's 15 knots. This is due to our ship's movement. Next thing, if true wind was there from north at 10 knots, then our apparent wind will be sum of both true wind and due to your ship's movement. That means ship movement, it was 15 knots and your true wind was 10 knots. The apparent wind will be sum of both, that will be 25 knots. So that means we'll see an example. Suppose this is your ship proceeding in a course of northerly at 15 knots. That's north into 15 knots. And we said ship was experiencing a wind from north. That means if a wind is named as north, that means it's coming from north and it's 10 knots. And in this case now you can see, due to the ship moving forward or ship moving northerly at 15 knots, there will be another force acting opposite to it, similar to the speed of the ship, that's 15 knots. That's due to ship's movement. And we know it's given true wind was from north, that's coming from north, and it's 10 knots. So you can see in this easily, these two forces are in same direction, so they add up. That means your final apparent wind will be adding up of both northerly into 10 knots true wind and 15 knots due to your ship's movement. That means they add up and apparent will become 25 knots. Similarly, if true wind was the south at 8 knots, apparent wind will be 7 knots due to ship's movement. So we can say now, ship was moving north at 50 knots as we said, and due to the moment of ship at 15 knots forward, we will be experiencing another force equal to the ship speed 15 knots due to the ship in opposite direction. And we said the wind is south, that means it's coming from south, and the speed is 8 knots. That means you can see due to the ship's movement and due to the wind, they are both cancelling each other, and since they are not of equal values, you can say they will cancel each other, and the difference will be, the final will be the value of highest and the difference between both. That means it's 15 minus 8, and they cancels each other since they are from opposite direction, and the final will be apparent 7 knots and this direction downwards because there was a highest one. So now let's see, how do we estimate wind at sea? We can see in open sea it is very easy to judge wind because there is no restriction for you. The wind is blowing easily here and there without any restrictions. That means you can easily judge wind. And how? Direction of wind will be at right angles to the line of waves. You can see the line of waves out at sea, and your direction of your true wind will be at right angles to the line of waves. This is how difficult to judge if both sea and swell are from different directions. When there was sea and swell and both from different direction, you will be having little problems to judge your direction of wind. And the force of true wind is judged by the appearance of the sea and comparison with sea state card. It is expressed in Beaufort scale, as you have seen in your ship. There will be Beaufort scale chart showing your force 1, force 2 till force 12. These charts are used to compare your sea state to judge what is the force of true wind. So yours in case of open waters, but in case of restricted waters like harbors, estuaries, like ports and all, estimation of wind is not that easy. So the wind force estimated by appearance of sea, as we do in open sea, will always be less than your true wind, actual wind. This is because wind has restricted fetch to blow over. That means due to your estuaries, harbors and all, there will be some restrictions for the wind to flow. So the actual sea state speed will be always less than your true wind. So another important thing is that when estimating wind force, it is always the time lag between increase of wind force corresponding increase of sea disturbance. That means your surging of winds happen mostly. So what happens is that it's always measured with the time lag between increase of wind force and the corresponding increase of sea disturbance. Next thing, one important thing, another method where we manually calculate true wind or apparent wind is using our wind triangle. So let's see what's wind triangle, and let's play it up. So in wind triangle we have 3 components. As we know, a triangle is always having 3 sides, and these 3 sides are 3 components in case of wind triangle. AT, the side AT is the course and speed of the vessel. O to T is the direction and speed of true wind. O to A is the direction and speed of apparent wind. So let's draw our triangle now. Suppose this is point A, it's always the first point that you draw in case of wind triangle, and we know from A to T is the course and speed of vessel. Suppose it was a course of 045, more like this. So we can say this was T. So this is our triangle A to T, and we know from O to A, that's your apparent wind. If you know the speed and direction of O to A, we can draw that, and O to T is always your true wind. So let's see what are each components of them. This angle is your angle A, that ship's head. That means we said this AT is the course and speed of vessel, and this angle is the ship's head, and this distance from A to T is your ship speed for that time duration. And next thing, normally we take it for 1 hour to solve your wind, because we calculate our wind speed and ship speed all in knots per hour, so that we can say it's always in 1 hour duration. Next thing is our O to A. It's always named O to A. As I said, wind is always named from where it is coming. That means even though it was angled, it was going from A to O, we are not naming it as 135 in this direction. It is always, we will not be naming it where it is going. It is always named from where it is coming. That means it's always from O to A. In what is where it is coming from, that is the name where it will be using in this case. Next thing is this distance A to O, that is your apparent wind speed in 1 hour. Next thing is our last type or last side of a triangle, that's T to O or O to T. That's our true wind direction. This will be the direction you will be having to use this perpendicular transfer this side to calculate your true wind direction. And this distance is nothing but your true wind speed. So we have all our sides of our triangle now. If you know any of one side, or if you need to know two sides, or at least minimum 3 components of this triangle to solve the rest of it. If you know ship speed and ship head, also the true wind direction and apparent wind speed, we can easily find apparent wind direction and true wind speed. We will see such types of problems in our following videos. Stay tuned to Ahoy Navigos. I hope you guys understood. Thank you.